Welcome to the EUMETSAT Year of Weather for 2023. We're starting right at the beginning of the year, winter in the Northern Hemisphere, summer in the Southern Hemisphere, and you'll see the pulsing of the tropical weather belt in the center. Mid-January, we're watching the Atlantic storms travel across Europe. Some of those storms are bringing very high wind and rain. So one of the storms that came over in the middle of January, 1415, came over France and Spain, recorded winds of 150 kilometers an hour. Turning to the south, you'll see the tropical cyclones and the hurricanes in the southern oceans, their energy coming from the warm water surface. We've put the label on the storms that were above a certain category. And you'll see as the storm season progresses how many storms there are. You can watch the progress of those storms over the ocean. Have a look at Storm Freddy, just forming off the coast of Australia. This particular storm had an incredibly long life, travelling away from Australia, across the southern Indian Ocean, towards Madagascar. These storms are incredibly powerful. They're amazing to see from the satellites, and the forecasters are able to watch their formation, to observe how they develop and forecast the track. At this point, Freddy is still travelling. It's travelled across Madagascar into the Mozambique Channel and is now coming across Madagascar again. It's an incredibly unusual storm event, and the entire journey was seen really clearly from our satellites. The warmer waters in the Southern Ocean are caused by the solar radiation, so the energy and the heat from the sun heating up the Southern Oceans. You'll see as the year progresses and the orbit of the Earth and its relation to the sun causes that heating to move north, that tropical band of clouds in the middle moves north. That's driven by the sun as well. So you see the daytime heating warms the surface, causes air to rise, form those tropical thunderstorm clouds, and then they decay overnight as you've got cooler environment and the cycle starts again. It's why you see that pulsating effect. So that's over a 24-hour period, that pulsating. And you'll see some of the storms moving along as the day progresses and the heating progresses. Have a look at where they are now, and you'll be able to compare with later on in the video where that tropical belt sits. It's called the Intertropical Convergence Zone, and it's part of where the air is meeting in global circulation and then is forced to rise up by that heating. So we're now moving to the end of April. If you look at Europe, we still have the occasional storm travelling across the Atlantic Ocean. But you'll also start to see there are days, particularly in the southern parts of Europe, where there's much less cloud. So for solar generation, this is great news because we're now starting to see more solar power being available. But also, we're starting to get into the much drier part of the year. As the year progresses and those warmer areas move further north, we now start to see some of the very earliest Northern Hemisphere tropical cyclones. So cyclones that are forming on the equator, particularly in the Pacific Basin. So they'll be moving towards the Philippines. You'll also see them in the Bay of Bengal fan, and some of them will be visible in the Pacific Ocean. One of the biggest storms of the year was Cyclone Manwa, also known in the Philippines as Cyclone Betty. And you'll see that storm forming just north of Australia and then travelling over towards the Philippine Islands. Manwa caused significant damage, particularly when it reached Japan. It also travelled over Guam and had some effects on the Philippines as well. Turning our eyes again to the Northern Hemisphere, what you'll see in the European area is less of those severe storms travelling across the Atlantic. We're getting much more stable weather. What we're showing you in these images is the clouds taken from the geostationary ring. They're from the infrared channels on board those satellites. And we're putting them on top of a natural Earth representation. So the green you see isn't live from the satellites. We do get growth information and agricultural information from the satellites. But here we're showing you clouds over a climatological area. In Europe, we're starting to build up a very dry situation. So quite a drought. And through the course of the summer, we actually saw quite some heat wave. The same was also true in North America, but that was accompanied with a really severe fire season. Now, in these particular images, we don't see the smoke so well. These can be seen by the satellites, but we need to look at channels there that are very, very sensitive to the smoke particles in the atmosphere. And when we look at those channels, and you can see some of these cases on the EUMETSAT website, you'll be able to see smoke from the Canadian fires that was travelling away from Alberta, the centre of Canada, over the eastern seaboard of the US, travelling across the Atlantic and reaching Europe. Many people were able to see the effects of that Canadian fire smoke in Europe in the sunsets. So the sunlight was being scattered by the smoke particles at sunset and making the sky that really deep red. Europe experienced a significant and sustained heat wave towards the end of July, beginning of August during this particular summer period. The anticyclone, so the high pressure, was centered over southern Europe, and what that was doing was driving the cooler air north and over other parts of the European continent. There was a 10-degree temperature difference, so Paris was experiencing 35, 36 degrees, whereas Athens was experiencing 45, 46 degrees, really high temperatures. And that leads to quite significant societal effects. So it was seen inside the hospital admissions and the demand for energy, for cooling, and people trying to find cooler spaces and safe spaces to be during these hot periods. Associated with this really warm summer, we also had some significant convective events. So this is the summer thunderstorms, where that heating on the ground lifts any moisture and causes large-scale thunderstorm events. And you'll be able to see those by those bright white clouds in the European areas they happen. As we move towards the beginning of September, we're also starting to see the real activity of the Atlantic hurricane season. Those Atlantic storms are born off the coast of West Africa. You see the flow of clouds, the waves traveling from West Africa into the ocean area. That ocean provides the energy that the storm needs, and some of those waves will start to organize and then spin. They pick up their energy from the ocean surface, and as they travel across and become more organized, they become more dangerous. Those storms take a while to develop, so they can be very, very well forecast. It doesn't reduce their effect in terms of the hazard, but it does reduce the damage and the loss of life and the loss to property as people are able to protect themselves. You'll also see storms continuing in the Pacific areas, both in the East and West Pacific. So we're heading into late autumn in the Northern Hemisphere. Those Atlantic storm seasons are carrying on. The cyclone season, the hurricane season, is still active. And some of those hurricanes will actually travel. They'll go maybe across the Caribbean, turn north, and then head towards Europe. Those are extratropical storms, and they can lead to very significant storm events in Europe. You'll see we've got more of the cloud events coming over, and there were quite some number of named storms for this winter season. One of the named storms affecting Europe was Storm Ciarán, that was running just towards the end of October, beginning of November. This caused huge rain and wind right across Europe. These storms are named in cooperation. So the weather services talk to each other, and they are named when people know that there's going to be a significant event. So the naming is part of the warning process. EUMETSAT, we're based in Europe, and we're focusing on providing services to our member states in Europe, but we also provide our images to partners all around the world so that everybody is capable of monitoring the weather and forecasting these weather events. The images that we show you here come from the global partnership. We're showing you data from our satellites over Europe and Africa and the Indian Ocean, the American satellites and the Japanese satellites. These are brought together by our colleagues in Météo France, thank you to you. And what that enables is a truly global, permanent, and continuous view of the Earth's weather system. Its primary purpose is for looking out for these storms and for monitoring changes in the Earth's climate. We have the full record of these data, which are used in studying climate change. But they're also really useful in understanding the Earth's system and the processes, so they're used by scientists around the world. So take the time to look at the storms and the weather where you live. Does it match your recollection of what happened in 2023? But also take a time to look around the world, to look at some of the weather patterns that are experienced elsewhere in our wonderful world.